Alright, hello everyone, my name is Ty Everett. In this video I'm going to be showing you how you can encrypt data for your users using the Babbage app engine. So what this is, I have pulled up here the starter Babbage app, right? The Babbage React starter, where you can create an action and you can click on this link here to learn the Babbage SDK. What we're going to be doing here is we're going to be using some user-defined keys to encrypt some data. This is useful for creating applications and services that respect privacy, and it is useful for sending encrypted data between users. So given a user bound to a key, that private key and the public key, you can use the private key of one user, user A, and the public key of user B to use Diffie-Hellman and exchange some information between those two users in a private manner. So that's one possibility with encryption. You can use it to encrypt data you store on NanoStore. You can use it to encrypt data inside of actions. So actions being these things that users do across all of the different apps they use. And without any further ado, we're going to get started with how you encrypt data. So what you're going to do is, I'm just going to start from the Babbage example here, where we have this button, right? And we have this button, and it's for creating an action. This is the Babbage React starter. There will be a link to this code repository in the description. And you can pull down this repository in order to follow along with this tutorial. So go to that link and follow those instructions. So now what we're going to be doing is we're going to be encrypting some information, and then we're going to be decrypting that information. So we have this button here, right? It says create an action. I'm just going to change this to Encryption Test. And then inside of our handler up here near the top, we're just going to replace this code with something closer to what we want. So set running true, that's fine, but we don't really want all of this stuff. So we have our try catch and all of this kind of framework, that is fine. But what we don't need is all of this. So we're going to go ahead and change our import here. So we're going to want a couple things from the Babbage SDK here on line 4. We're going to want encrypt, and we're going to want decrypt. So you can take something out of a text field if you want, but in this case we're just going to be saying data to encrypt equals this is a test. So this data can be anything you want that you want to encrypt using the keys that belong to the user. And then we're just going to follow the API, right? What does the API say about how we can use encryption? So we're going to pull up the documentation for the Babbage SDK. So if you want to follow along here, the documentation link is also going to be in the description. So this just summarizes some of the high-level attributes of, Babbage, the users, their keys, how all of that's set up. But we're going to go to the api.md file here. So this is what's going to be linked, and we're going to look at the encrypt function. So how does this work, and how can we use it to, create applications that protect privacy? So encrypts data with a key belonging to the user, also allows data to be encrypted with the asymmetric keys between two users with an ECDH shared secret. So in this case, we're going to be using symmetric encryption just to create, create a message that we've kind of encrypted using a user's key, and then we're going to decrypt it again. So this can be used to encrypt any number of things that belong to users. We're going to have args.data, and this is going to be the data that we want to encrypt. That's going to be one parameter. Key, and that's what key are we encrypting. And then the path on that key. If we want to use ECDH, then we would provide the public key of the foreign user, and it would derive the key and encrypt it using the shared secret. You can also specify a return type for the data that has been encrypted, so string or uint array. You can provide the reason, which is used when we're doing things with the privileged key set. Privileged key sets are a bit more strict with their security, and so they're going to ask the user for permission every time we use that. So I'll demonstrate that here in just a second. Finally, we've got sequence. That's useful just for, elliptic curve, Diffie-Hellman, and then originator, which doesn't mean anything for you. That's just an internal thing, and it actually shouldn't really be exposed. So we've got our data here that we want to encrypt, right? We're just going to say const encrypted data is equal to await encrypt, and now we're going to follow the API. So we're going to say data, and we're going to say binary. Is it B2A? Binary to ASCII. And we're going to say data to encrypt. So there is that. And I may change that, but I think that's the correct way of doing that. We're going to want the key. And in this case, we're just going to say, primary key. And we're going to be using an open path. So if you don't know what that is, just each key that the user has, they also have subpaths and subchildren of their keys. So each key can have, a couple of billion child keys, and so we that's the root, and then we have the 1033rd child, that's the open path, so anything under this is allowable by anybody. We don't need to deal with permissions or anything like that. Just for this demonstration, there's going to be other content coming out about app permissioning and all of that stuff in other videos and on the website at projectbabbage.com. But in this case, we can just pick, level. We can just say the 5th child of the open path on the primary key set, and that should actually be everything that we need to do there. So now we're just going to save this, and we're going to get a warning because decrypt is not defined, or it's not been used. But that's fine because, we haven't gone there yet. So I'm just going to tab back over here. Now we can see that this button has changed. It says Encryption Test. We'll just go ahead and click on this here. And we actually see some garbled text in the console. So this is the encrypted version of the text that we just kind of encrypted using the keys that are only held in Babbage Desktop, only held by these users. So as the app developer, I don't have access to the key that can be used to sort of decrypt that. And the only way that somebody can decrypt it is if they're using the same exact path, the same exact, key on that same exact path. So this string of text is encrypted specifically for this user, and only when this user is signed in on their devices using their account will they be able to decrypt this. So you can store this encrypted text on your servers or in Bitcoin transactions or whatever else, and it will only be accessible to the person who is actually supposed to be able to see it using the application that you've created. So no, it's a much more privacy enforcing model for managing data, because the only way we can get this back is by using the decrypt function, but also when the user is signed in to their device. We cannot just use we can't just pass that same, piece of text, that garbled piece of text we just saw into a decrypt function on another device or when another user signed in, because it won't work. Only me, as the person who encrypted this, is going to be able to access the decrypted value. So now let's go ahead and decrypt the thing we've just encrypted. So we're going to say now decrypt, right? And we're going to pass in the ciphertext. That, I believe, can be passed in without using B to A because it's already in that format, the base 64 format. So we're just going to say encrypted data. We're going to say the same key, right? Because if we don't use the same key, then we're not going to be able to get this back. And the path on that key, m/1033/5. So now we've got this, and we can log that. We can also log decrypted value. And actually, I'm going to move this log up here just so that we can see the one as it comes in. So we'll save that. That should make that all green. I'll go ahead and refresh this page here to clear out the console. And now we're going to click on this button. So what we can see is that it looks like it did. I bet if I were to copy this, I seem to have messed up, but it's ASCII to binary, right? That's our value back. So what we really need to do here is console.log, and we need to say ASCII to binary. So we go binary to ASCII when you send things in, and you go ASCII to binary when you get them out. So that's saying, you know, this is not defined, whatever, but that's actually fine. Same like the one up there. So we've got this value here, and it's saying it's assigned a value but never used. Oh, see, I accidentally made that into a string. So that should solve that problem. And now if we save this and try again, we hit the button, and we can see that we get the data encrypted, and then and this is a different garbled piece of data every time, and then it gets decrypted. It gets decrypted sort of. Oh, it does cache it. So this gets decrypted using the decrypt function. But let's do a little experiment here. If we were to change this and say, you know, maybe I changed that from a 5 to a 4 on decrypt. Now we're trying to encrypt it with key at 5, and then we're going to try to use the key at 4 to decrypt it. And we get, you know, this, it looks like something went wrong. It gives an error, right? Decrypt through, and it says decryption failed. That's because we are not able to use that key to decrypt that value incorrectly. So the last thing I really want to do in this video here is change this to the privileged key. And what this will do is it'll give you a little bit more security. So for high security things, if you're encrypting something like a secret message or something that you know is slightly more important or valuable, you may want to use the high level, you know, the privileged access mode for encryption. So I'm going to close this error here. I'm actually going to refresh the page again. And when I hit encrypt, it's actually going to suspend the operation, right? So we have that async await. Then it's going to ask me for my password. And it says a third party is attempting to obtain access to your privileged key without providing a reason. So I'm going to hit cancel here because obviously, right now we get an error. Encrypt through, you know, that the user has aborted this operation, and that's just because I hit cancel. Now we're going to figure out what that reason is for. So we're going to give the reason, and you know, we can say we'll do lock up a very important document. And now I'll go ahead and refresh this again just to clear the console. We'll go ahead and run this encryption test, and we can see that the, you know, it's saying enter your password, lock up a very important document. So I'll enter my password, and once my password has been entered. I can hit OK. That appears to be the wrong password. So now it actually wants, so here's what happened, right? It's saying there's no, it's going back to here. But if we look in the console, up at the top, it's actually already encrypted that value. But the thing with the privileged key is that every operation that requires it is going to ask the user for authorization. So we provided a reason on encrypt, but when we're using privileged key for the decrypt down here, line 36, we did not provide a reason. So when we want to decrypt it, we need to enter the password a second time. And I'll go ahead and just kind of tab back over here. And now we can see that we were using the privileged key to encrypt and decrypt that value there, right? We're now in this position where we can use the primary key set for everyday encryption operations, and then we can use the privileged key set for things like more highly secure applications. So I'll just demonstrate one example of going ahead and using the different modes of operation. We're using the encrypt function a lot to protect user messages and profiles in Convo Messenger. So we can see all of these messages, but some of them are locked, right? So we have at the bottom here, you can see, do you want to send the message as a secret message, or do you want to send it as a normal message? So all of the normal messages and normal photos were done using the primary key set, but all of the secret ones that are locked here, we can see secret text, and we got secret photo. All of these are done, so I have to actually enter my password. I notice it's the same password on all of my applications because the keys are managed locally, but I can then decrypt the secret text there, this beautiful piece of poetry. And that's an example of, and this is also incorporates the elliptic curve Diffie-Hellman exchange. So, the shared secret to allow these messages to be read both by the sender and the recipient. But this is an example of encrypting data in practice. So now you know how to encrypt data using the Babbage app engine. So you can use that to provide better privacy to your users, allow them to perform operations with keys that only they have so that they can be more in control over their data and their experience on the internet. And I hope this has been a valuable kind of a video tutorial. So as you build apps with Project Babbage, definitely check out the other videos on this channel for how do you deploy your app? How do you make money from your app? Why is this privacy-centric model going to work from an economic point of view? And definitely reach out if you have any questions. You can find us on projectbabbage.com, and I'll see you in the next video.